The International Space Station costs over $1 billion a year to maintain, and the biggest culprit, friction. In the vacuum of space, a single bearing failure can be catastrophic, but NASA just cracked the code with revolutionary breakthroughs that will change space exploration forever. So why is friction such a colossal problem in space? On Earth, we have a secret weapon we barely even think about, the atmosphere. It provides a thin layer of gas that separates surfaces, and it allows us to use a huge range of oils and greases. But in the vacuum of space, those lubricants would just evaporate, gone, leaving bare metal to grind against bare metal. And when that happens, you get something called cold welding. The atoms of the two metal pieces literally don't know they're separate objects. They bond together, seizing the mechanism solid. Imagine a solar panel that can't track the sun, or a robotic arm frozen in place. That's a mission-critical failure. For years, NASA and other space agencies have relied on solid lubricants like graphite or molybdenum disulfide. Think of them as a deck of cards. The layers can slide over each other, providing lubrication. But even these have their limits. They wear out, and at the extreme temperatures of space, which can swing from a scorching 250 degrees Fahrenheit in the sun to a bone-chilling minus 250 in the shade, they can break down. This brings us to the heart of the problem. Bearings, tiny metal balls that allow things to spin smoothly. The ISS is packed with them. They're in the solar alpha rotary joints that turn the station's massive solar arrays, in the control moment gyroscopes that keep the station stable, and in countless pumps and fans that keep the astronauts alive. And as a 2014 NASA report on the ISS centrifuge bearings made clear, a single bearing failure can be a nightmare. Replacing one in space is, to put it mildly, not easy. It can require multiple spacewalks, risking astronaut lives and costing a fortune. So, for decades, the solution has been to over-engineer everything, to build in redundancy, to use the best, most expensive materials, and to hope for the best. But as we plan for longer and more ambitious missions to the Moon and Mars, hoping for the best just isn't good enough. We need a new solution. We need to get rid of friction altogether. What if you could make two surfaces fly? What if you could make them hover, just microns apart, so they never, ever touch? That's the magic of magnetic bearings. And in 2023, NASA installed a new piece of hardware on the ISS that does exactly that. This is the new 4-bed carbon dioxide scrubber, a critical piece of life support that cleans the air for the astronauts, and inside it is a revolutionary air blower that spins on a cushion of magnetism. No contact, no wear, no friction. Think of it like this: you have a ring of powerful electromagnets. Inside that ring, you have a shaft. By precisely controlling the power to each of those magnets, you can levitate the shaft right in the middle. It's a constant, delicate balancing act, with sensors taking thousands of readings per second to make sure the shaft never drifts off-center. The result? A system that can spin at incredibly high speeds with virtually zero friction. This isn't just a fancy fan, it's a game changer. For years, the fans and pumps on the ISS have been a major maintenance headache. They use traditional bearings that wear out and need to be replaced. But this new magnetic bearing system could, in theory, last for decades. It's a fit-and-forget technology, which is the holy grail for space engineering, and the implications go far beyond just cleaning the air. Imagine this technology in the gyroscopes that keep the station stable, or in the pumps that circulate coolant. Or looking to the future, imagine it in the wheels of a lunar rover, or the drills we'll use to search for water on Mars. Any place where you have moving parts, magnetic bearings offer a future free from the tyranny of friction. But what about the places where you can't use magnets? What about the surfaces that have to touch? For that, you need a new kind of material, a super material. And NASA has been developing one that sounds like something out of science fiction. It's called Ni-Ti-AHF, or nickel titanium hafnium. It's a type of shape memory alloy, which means it can be bent and deformed, and then it will return to its original shape. But it's also incredibly resistant to wear and corrosion. It's like a self-healing metal. Traditional steel bearings can be brittle. A sudden shock or vibration can cause a micro crack, and over time that crack can grow until the bearing fails. But Ni-Ti-HF is different. It's super elastic. It can absorb shocks and vibrations that would shatter a normal bearing. It's the perfect material for the harsh environment of space, where you have everything from micrometeoroid impacts to the vibrations of a rocket docking. But what if you could take this a step further? What if you could create a material that not only resists wear but actively lubricates itself? That's the idea behind a revolutionary new breakthrough from a team of researchers at Virginia Tech working with NASA. They've discovered a way to create a self-lubricating metal. By using 3D printing or additive manufacturing, they can create a metal surface that, when it gets hot, actually grows a thin layer of a special kind of ceramic called a spinel. This spinel layer is incredibly slippery at high temperatures, acting as a built-in, constantly regenerating lubricant. This is a huge deal. Most lubricants, even solid ones, break down at around 600 degrees Celsius, but these spinel layers can handle temperatures that would melt lead. This is the kind of technology you need for the next generation of rocket engines, for hypersonic vehicles, and for deep space probes that have to endure incredible heat. And it all started with a question. How can we make materials smarter? How can we make them work with the extreme environment of space, instead of just fighting against it? The answer, it turns out, is to build the solution right into the material itself. But the innovation doesn't stop with solid materials. NASA is also revolutionizing the world of liquid lubricants. The problem, as we said, is that in a vacuum, liquids tend to boil away. But what if you could design a liquid that has virtually no vapor pressure, a liquid that simply does not want to evaporate? Welcome to the weird and wonderful world of ionic liquids. These are essentially salts that are liquid at room temperature, and because they're made of ions, charged particles, they have incredibly strong bonds that hold them together. They have such low vapor pressure that they can survive in the vacuum of space without boiling away. For years, the go-to ionic liquids for space have been fluorinated, meaning they contain fluorine atoms. They work well, but fluorine can be a problem. It can be corrosive, and its long-term environmental impact is a concern. So, a team at NASA's Marshall Space Flight Center, working with the University of North Carolina, has been developing a new generation of non-fluorinated ionic liquids. This is cutting-edge chemistry. It's about designing molecules from the ground up, tuning their properties to create the perfect lubricant for the harsh environment of space. It's a slow, painstaking process of synthesis and testing, but the payoff is huge, a new class of lubricants that are not only effective, but also safer and more sustainable. And this highlights something really important about how NASA solves these problems: collaboration. It's not just one genius in a lab, it's teams of scientists and engineers from NASA, from universities and from private companies, all working together. The Virginia Tech Spinel lubricant involved a consortium of 6 universities. This is a massive nationwide effort to conquer friction. So, what does this all mean? It means we're at a turning point in the history of space exploration. For 60 years, we've been fighting a defensive war against friction, a war of attrition. We've been trying to shield our machines from the harsh realities of space, but now we're going on the offensive. We're not just fighting friction, we're outsmarting it. We're using the laws of physics, of chemistry, of materials science to create systems that are not just resistant to the space environment, but are actually enhanced by it. We're building machines that lubricate themselves when they get hot, that levitate on cushions of magnetism, that are made of materials that can heal themselves. This is the future, a future where our machines can operate for years or even decades without maintenance, a future where we can build permanent bases on the moon and send long-duration missions to Mars without having to worry about a single bearing bringing the whole mission to a grinding halt. The silent, invisible war on friction is being won, and the victory will be measured not in battles, but in the new worlds we will be able to explore. The next giant leap for mankind might not be a footstep, but the frictionless spin of a perfectly designed bearing, taking us further than we've ever gone before. Thanks for watching. If you want to know more about the incredible science happening on the ISS, check out this video here. And let me know in the comments what you think is the biggest challenge for future space exploration. Don't forget to subscribe for more stories about the amazing science that is shaping our future. See you next time.